Alright, so welcome back. Chapter 9, Section 4 for Note-Taking Guide video lesson. This section is entitled Graph and Write Equations of Ellipses. Now, for circles, it was very straightforward. There wasn't a whole lot to cover. But since an ellipse is basically a circle that's maybe had some pressure applied to the top and bottom, so it's more of an oval shape. So an ellipse is the set of all points such as it's the set of points that the sum of the distance, so we'll say the set of points where the sum of the distances between the point and two fixed points is equal. All right. So basically, when you had a circle, you had a center, and this radius was all the same. The center to the circle was exactly the same. For an ellipse, though, it's been smashed. And so, yes, you still have a center, but you can see the center is closer to the top and the bottom. So what happens is, you have a point here and a point here. And basically what happens is you say that the distance, here's a point, that this distance plus that distance is the same as this distance plus that distance, which is the same as this distance plus that distance. Basically, it's just all the same. You're not going to have to be able to find those points, that distance, but you will be asked to know what these numbers right here and right here is. The foci are the fixed points. And there'll be an easy way for us to tell you what those points are. Vertices. The vertices are the points at which the lines through the foci intersect the ellipse. Point where the line intersects the ellipse. Basically what it is, if you have your ellipse shape, okay, the vertices are there in red. They are the vertices, you could say, the tips of the ellipse. So what that means is if you had an ellipse that looked like this, you can see this is more of a vertical ellipse. The vertical ellipse. The vertices are the tips. So we're going to jump down to covertices. And they are the other ones. They are the points when the perpendicular line intersects the ellipse. basically what you can say is you could say that they are the squashed tips of ellipse. So this could be a vertice, except that it's the squashed ends. So these ones here are the co-vertices. This is just the straight up vertices. The red ones are the vertices. All right, let's go back over to the major axis. It's a segment, a line segment that joins the vertices. So basically what you have is you have an ellipse. There's a wonderful ellipse right there. You have vertices here and here, and there's a line segment that connects them. That is the major axis. Now, minor axis would be a segment, a line segment that joins the co-vertices. So basically, this is a co-vertice. Co-vertice here is the minor axis. The center point is right here. You could say the point where the major and minor meet. Now, what you're going to notice is that this right here, this distance and this distance are the same. This distance and this distance are the same. Basically, what you can do is the major axis and the minor axis are perpendicular bisectors to each other. And perpendicular bisectors, if you go back a couple sections, you'd see exactly what I'm talking about. So, all of these have a standard equation of an ellipse with a center at the origin. All right. What happens is it looks a lot like a circle. X squared plus a y squared equals 1. The problem here is that this and this, you're going to have a fraction. It's still a plus. Everything's still positive. The major axis for this is horizontal, and the vertices are at plus or minus a, and the co-vertices are at plus or minus b. Now, if you look here, the major and minor axes are the lengths 2a and 2b, respectively, where a is greater than b is greater than 0. The focus of the ellipse lies on the major axis at a distance of c units from the center, where c squared is equal to a squared minus b squared. All right. Basically, what we're looking at here is that a squared, b squared, one of them will be bigger than the other. So let's take a look. Let me add a new page here. Let's see here. Can I draw a shape? No. All right, so while I was away, I went ahead and drew an ellipse. This is a vertical. It has a vertical major axis. As remember, major axis, segment that joins the vertices. So keeping that in mind, that means this point and this point are vertices. That's one of the vertex. The minor axis goes through the co-vertices, so it's here and here. This is a co-vertex. So what we're looking at for this is that for a vertical one, this should be plus or minus a here, plus or minus b for the co-vertices. So that means right here, for a vertices of a, this should be 0, negative a. This should be 0, positive a. This should be b, 0. And this should be negative b, 0. And it all has to do with which one of these is bigger. So since a is bigger in this situation, you can see that a is further away from the center. So for this one right here, since it's horizontal, now you can see this is a covertex, and it's the distance from the origin goes from 0 up to b. So that means the b part is smaller, 0 down to negative b. The vertices are here. The vertices are right here. And there, since a is bigger, it's at a0 and negative a0. So that's how you can come up with those vertices. That's how you get the equation. Look, x squared, y squared. All you're looking for is the distance from the origin to the vertex and the distance from the origin to the covertex. So you're going to probably end up using the equation twice. So here's our first example. And I apologize, this video is going to take a little longer than the last one. Here's our example. Graph the equation 9x squared plus 36y squared equals 324. This equation is not in the standard form. The standard form says it has to be x squared over something squared plus y squared over something squared, and it has to equal 1. So this is the key, the 1. Right here, it's 324. How would you go about making 324 a 1? Now some of you may say subtract 323. Well, you can do that. That would be a 1, except it'd really screw up the other side. So instead, take this, divide by 324. So what you've got now is you've got a 9x squared over 324 plus 36y squared over 324. Now it equals 1. So we've done very good at making this equal to 1. The problem here is that now this is not a 1x squared over a squared. But if you go ahead and reduce this, if you take a look, what is this equation if you do 9 over 324? You end up with x squared over 36 plus y squared over 9 equals 1. So what we're looking at here, since this number is larger than that number, since the first number, it's a horizontal graph. Let's rewrite it like this. 36, of course, is 6 squared and 3 squared. So that means here, this number is bigger. So one of the distances is 6. One of the distances is 3. So we start right there at the origin. It says to graph the graph the equation. Graphing the equation, we're at 0, 0. We're at 0, 0. And we go 6 out, 2, 4, 6. Here is a vertex. 2, 4, 6. Here is a vertex. 2, 3, a covertex. 2, 3, a covertex. And let's see if I can draw an ellipse on top of that. And there's our ellipse for that graph. It says to label, identify the vertices and covertices and the focus of the ellipse. All right, this is where we doing the foci is going to be the tough part here. We've identified this is a covertex, this is a covertex. You should be able to know that this is 0, 3 just by looking at the graph. 0, negative 3. Should be able to know that this is 6, 0, and this is 0, 6. The problem now is coming up with the foci. And what you're going to want to do is go back to here where it says the foci of the ellipse lies on the major axis at a distance of c units from the center. A squared minus b squared. So, since a is 6, so the center, or the c squared, is equal to a squared minus b squared. So c squared is equal to 6 squared minus 3 squared. That's 36 minus 9. That's 27. You square root it. And this now says that the foci is plus or minus the square root of 27 from the center. So plus or minus 27, that's about 5.2. So you come here, 2, 4, 5.2 is right here. 2, 4, 5.2 is about right there. Those are your foci. Now, if you came up with the co-vertices and vertex, coming up with a foci is kind of moot point at this point. But here's another example. Write an equation given this information. Write an equation of the ellipse that has a vertex at 0, 7, 0, 7, 2, 4, 6, 7. 0, 7 is 0, 2, 4, 6, 2, 4, 6, 7 right here. That means then the other vertex is down below, 2, 4, 6, 7. It has a co-vertex at negative 4, so 2, negative 4, and 4. You should be in a center at 0. All right, so what you've got here, you now have an ellipse. You now have an ellipse that you can find an A value and a B value for. So start by saying, what is this distance? What is the distance here from the center? Well, 2, 4, 6, that's 7. What is the distance from here to here? Well, that's 4. So what you got to look at now, you have to look at the fact that this is a vertical ellipse. And vertical ellipses, if A is the vertical one, so this is A. And this is B. And now we go ahead and write your equation. And all you have to do for this is divide by A and B squared. So, since this is a vertical one, the vertical, the smaller number comes here, so it's 4 squared. That's 7 squared. That means my equation is x squared over 16 plus y squared over 49 equal to 1. So all you have to do is plug those numbers into the right A and B part, and you're good to go. So this right here was fairly easy. Finding these vertices takes a little more work sometimes. All right, write an equation of the ellipse that has a vertex of -6, 0, and a focus of 5. All right, so we know it has an ellipse that has a vertex at -6, 2, 4, 6, -6, 0, which means this would be 6, 0. It has a focus of 5, 0. All right, remember where c squared, the distance is a squared minus b squared. So since it has a focus at 5, this is 5 squared. And since it says that this is a these red ones are the vertices and not covertices, that means that somewhere between 6 and 0 is the b value. So this is a horizontal one. A for this one is 6, and then minus b squared, which we do not know. That's 25 equals 36 minus b squared. Let's subtract 36 from both sides. So when you subtract 36 from both sides, you get -11 equals -b squared. So you divide everything by -1, 11 equals b squared, and your b value is the square root of 11. So just by using this distance formula, you now can say that since a is 6, since b is the square root of 11, you plug it into the equation, the standard equation, x squared over y squared over equal to 1. So a is 6, so that's 6 squared. B is square root of 11, so that's square root of 11 squared. And you end up with the equation x squared over 36 plus y squared over 11 equals 1. All right. Graph the equation, identify the vertices, covertices, and the focus of the ellipse. This one looks a little bit different, but it shouldn't throw you because all you're dividing by is 1. Therefore, x squared over 1 squared equals plus y squared over 5 squared equals 1. This is now in standard form. And since a is always bigger than b, that means a is 5, b is 1, and since, again, a is greater than b, and like I said, since a is greater than b, the a value goes with underneath the y for the vertices. So that means vertices are at 0 plus or minus 5. The covertices are at 1 plus or minus 1 comma 0. So we can plot those points there. This is a scale of 2. So we got covertices, regular vertices. Draw your ellipse in there if you want. So vertices, check. Covertices, check. Draw the vertice in there. I'll see what I can do. There's your ellipse. And now comes the foci. Remember, the foci for these is the distance from the origin on the major axis. It's a squared minus b squared. So for us, a squared is 5 squared minus 1 squared. That's 25 minus 1. 25 minus 1 is 24. When I square root both sides, c is approximately 4.9. So I'm gonna have difficulty drawing that in there. It's about right here and right here. All right. You use this to find the focus, and you use your understanding of where B and A are located in the equation. More problems here. So let's try. Let's give them a try. Write an equation of the ellipse with the given characteristics and center of 0, 0. All right, we have vertex and covertex. Since this number is larger, meaning bigger, 9, -9, +9 is bigger than -4, +4. That means that this is A, and it is underneath the x squared. So the A value goes underneath the x squared, the B value goes underneath the y, and you have an equation of x squared minus 81 plus y squared over 16 equals 1. Remember, whichever number is bigger when it comes to the vertices or covertex, that goes under. So here, this is in the x place, so it goes under the x. This is in the y place, it goes under the y. Number 3, we know part of the equation. We know that the vertex is at 0, 7. Since 0, 7, that means this is your A value. And your bigger number goes with the y since it's in the y's position. So let's take a look. Focus is the c squared equals a squared minus b squared. We know that c is -3 squared equals 7 squared minus b squared. Go ahead and work some of this out. That's 9. Let's subtract. That's 40, or -40. Divide by negative, so 40 equals b squared. Therefore, your b value is approximately the square root of 40, which is approximately 6.3. But we'll leave it at square root of 40. So now, what we're looking at here is the equation x squared over something, and it all equals 1. So, remember, the vertex here was 7, right there. It's underneath the y. It's in the y's position, so you go under the y, so that's 7 squared. And that's the square root of 40 squared. So my equation is x squared over 40 plus y squared over 49 equals 1. All right, like I said, we're going to do a lot of these problems in class, but this should give you a basic understanding of how to do some of them. I would recommend doing them, working through a few of them, and coming to class somewhat prepared to do the rest. So, good luck with these problems. We'll see you soon.